Hello, my name is Armand Rai, and today we're going to be talking about what is I to a power. I'm in Sister Kathy's 2 white class. Before we talk about what is I to a power, we have to review some things. What's a to the x times a to the b? Well, these are like bases. So we're going to keep the like base. We're going to add the exponents. So it'd be a to equals the x plus b. And if we're going to do division, we have a to the x divided by a to the b. We're going to subtract it. So it's going to be a to the x minus b. And if we have a root of a number, and then we square it, it's going to still be that number. Another property is that if you take the square root of a number and multiply it by the square root of that number, you get that number. Now these are very self-explanatory things, and you can plug in numbers if you want, but these are crucial when we talk about and when we go further. There's going to be other things. These properties can also be worked the other way around. So if you have a to the x plus b, you can break that down into a to the x times a to the b. Now let's have some examples. What's the square root of 25? Well, that's 5. Everyone knows that. What's the square root of 9? Well, that's 3. Everyone knows that. What's the square root of, let's say, 64? Well, that's 8. Everyone knows that. What's the square root of 16? Well, that's 4. Everyone knows that. This is all very simple. You're probably saying, Armand, what are we doing? This is first grade math. Well, let's bring in a new concept. What's the square root of negative 25? Well, from up here, we know that that also equals the square root of 25 times the square root of negative 1. We know that. That's right up here. That equals 5 times the square root of negative 1. But what is the square root of negative 1? That's the main topic of the day. The square root of negative 1 is equal to I. I is not a real number. The square root of negative 1, you cannot pinpoint it on the number line. So it does not exist, but it is very useful in some more complex problems. Now, I has its own set of properties. So let's take I squared, I cubed, and I to the fourth. Well, I to the first is just I. Every number to the first is itself. Now, what's I squared? Well, I squared is I times I. That didn't really help us that much. That was pretty stupid. But that means that it's the square root of negative 1 times the square root of negative 1. And we know that the square root of a number times the square root of a number equals that number. So that means equals negative 1. So that means I squared equals negative 1. What about I cubed? Well, we know from up there that we can talk about that I cubed is I squared times I. Well, we know I squared. We just did that. Let's plug it in. I squared is negative 1 times I. And that equals negative I. Now you may be saying, Armand, shouldn't it be negative 1 times the square root of negative 1? And it would be negative square root of negative 1? Well, in a way, yes, you're right. But it's more commonly written as I, and anywhere if you see it on a test or see it in real life, then it's going to be written as I. Now it's I to the fourth. Well, I to the fourth equals I squared times I squared. Well, we know I squared, so let's just plug that in. Equals negative 1 times negative 1. What's that equal? That's just 1. So, you know, I to the first equals I squared equals negative 1, I to the third equals negative I, and I to the fourth equals 1. Now, I has this weird set of property that every 4, the cycle repeats. So that means I to the first is going to be the same as I to the fifth. So that means I to the second is going to be the same as I to the sixth. I to the third is going to be the same as I to the seventh. I to the fourth is the same as I to the eighth. Now, let's prove that to make sure it's true. Let's just use I to the third and I to the seventh. I to the third, we know from up here, equals negative I. Now, let's see what I to the seventh is. Well, we know that I to the seventh equals I to the third times I to the fourth. What's I to the fourth? I to the fourth is 1. We know any number multiply that by itself is itself. So I to the third times 1 equals I to the third. Now, you may realize that means, well, whenever you have a 4, it basically just gets canceled out because it doesn't really matter. And you're pretty much right. So if you have I to, let's say, the 13th, that equals I to the 4th times I to the 4th times I to the 4th times I. And that just equals I, because I equals I. Now we can rewrite this as 12. I to the 12th times I to the 1st, because we know that that equals I to the 13th, because we can add those according to our property up here. Now, why does this matter? Well, we know 12 is a multiple of 4. So that means that if we can take a number, let's say I to the a, we can take a and divide it by 4. Whatever the remainder is, let's call it x. This is what you put I raise I to. So let's say you have I to the 70th power. Well, let's take 70 over 4, and we know that 68 is a multiple of 4. And so what's 70 minus 68? Well, that's 2. So we have, if we take 70 over 4, we get however 68 is, and the remainder of 2. So we're going to take this remainder of 2, and that's what we're going to put I by. That's negative 1. So this works with everything, really. If you have I to the, let's say, 100th first power. Well, we know that 100 is divisible by 4. So let's do it. And that equals 25. So we're going to take 101, divide by 4, and we know that's 25, remainder 1. So that means we're going to take I and bring it up to the first power, which is known as I. So I'm going to just write down a couple of practice problems. If you need to pause the video after I write them down, you may. I'm going to give you a couple seconds. What would I to the 363rd power be? And what would I to the negative second power be? You can pause the video if you need to. Okay, so 363. We know that, I'm going to get a more thinner ink. We know that 360 is divisible by 4, and that's 90. So we're going to take 363, divide by 4, and that's 90, remainder 3, because we had 360 is divisible by 4, and 363 minus 360 is 3. Well, fine, we found a remainder. Let's cube it. So I cubed is, as we remember earlier, it's negative I. That's simple. But what about I to negative 2? Well, we know that when you have any number, and you have it to a negative power, you put it in a fraction. So if you have a to the negative 1, it equals 1 over a. Or if you have a to the negative 73rd, you get 1 over a to the 73rd. So let's bring it up here, and we're going to take, so this equals 1 over I squared. Armand, we're done. No, we're not. Look, we still have that. Are you blind? So we're going to take 1 over, what's I squared? Well, it's negative 1, because if you remember earlier, I equals the square root of negative 1. Now, this is a very simple concept if you just think about it, and it's really an interesting concept also. The main thing you have to remember is that find the nearest multiple of 4, the greatest common factor, the greatest multiple that they both share with 4 in it. So for example, we found 360 within the 363 because that's the greatest multiple of 4 in 363. Subtract it from that, as you see right here, we subtracted 360 from 363 and got 3, and then that's what you raise I to. Thank you for listening. Again, it's Armand Rai and Sister Kathy's 2 white class. Hope you enjoy.